Alright, PreCalc, here we are with 10.4 hyperbolas. Pretty similar to what we've done in Algebra 2 with hyperbolas. Just like I said, a little bit faster. Maybe a few applications that we didn't do before in Algebra 2. Maybe you already did those. We'll see. What we should learn. Be able to write equations of hyperbolas in standard form. Find asymptotes of and graph hyperbolas. Use properties of hyperbolas to solve real-life problems, and classify conics from their general equations. For this video today, we might get through the first two, maybe three dots. Maybe three. Probably just the first two. Alright, our third type of conic is called a hyperbola. The definition of a hyperbola is similar to that of an ellipse. The difference is that for an ellipse, the sum of the distances between the foci and a point on the ellipse is fixed, whereas for a hyperbola, the difference of the distances between the foci and a point on the hyperbola is fixed. Okay, so I had to reread that because down here I was like, oh, this is going to stay the same? Well, that should be round, but it's the difference, not the sum, the difference. So D2 minus D1 stays the same. So as we get further and further up the branch up here, this one's also going to grow a little bit, and then the difference should stay the same. Okay, the graph of a hyperbola has two disconnected branches. The line through the two foci intersects the hyperbola at its two vertices. The line segment connecting the vertices is the transverse axis, and the midpoint of the transverse axis is the center. So you can see all the details there, your A distance, your C distance. Your B distance with the co-vertices isn't always shown. We can graph those when we do them. That can help make your rectangle in the middle, which helps you draw your asymptotes a little more accurately. But the book doesn't really ever use the B numbers or your co-vertices, but we can use them. Okay, very similar to the standard form for an ellipse. Pretty much different. The only difference is that we got a minus in the middle. And for those of you scrambling to write that down, guess where you can find that, where it doesn't move in your textbook. Okay, we had x minus h squared over a squared minus y minus k squared over b squared equals to 1. You'll notice that one difference we have here is that the a is always the positive one. They changed that around. That might be different from how you learned it in Algebra 2. The a is always with the positive one in this case. Okay, and then our formula to find C, to find the foci, is a squared plus b squared equals c squared. So that changed for us. Before it was big minus little. So just keep that in mind. All these little subtle differences from one to the next. Okay, 10.32 shows both the horizontal and vertical orientation for a hyperbola. Notice it's just the difference there between which one's positive. Is the x group positive or is the y group positive? If the y group is positive, it goes up and down. If the x group is positive, it goes side to side. Alright, example 1, hopefully a piece of cake. Find the standard form of the equation of the hyperbola with foci with -1, 2, and 5, 2, vertices at 0, 2, and 4, 2. Okay, so step 1, we need the center. Either way, you'll notice that the midpoint of the foci should be 2, 2, Or if you look at the midpoint of the vertices, we should still be at 2, 2. So my center is 2, 2. So we'll have x minus 2 squared minus y minus 2 squared. Okay. Next, let's draw a little sketch. So I've got my 2, 2, 0, 2, and 4, 2 for the vertices, and foci at negative 1, 2, and 5, 2. So maybe if we did that one first, that quick little sketch first, it'd be a little more obvious that this is going to be a side-to-side one. And that's how I had x first. Okay. So the distance here from the center to a vertice, that's a length of 2. That's your A. And then from the center out to the focus point is 3, and that's your B. Nope, that's your C. Lied. I'm a liar. So we have A squared, 2, plus B squared equals 3 squared. So we have to find a B. So we have 4 plus B squared equals 9. B squared is going to equal 5. And that's all we really need is the B squared part, because that's what's going under here. But if you wanted to do that, you could. And then we had that 2, so 2 squared would be 4 under our x. And there it is, x minus 2 squared minus y minus 2 squared. We have the x minus 2 squared over 4 and the y minus 2 squared over 5. Okay, asymptotes. Each hyperbola has 2 asymptotes that intersect at the center of the hyperbola as shown. The asymptotes pass through the vertices of a rectangle of dimensions 2a by 2b with the center at h, comma k. So this is what I was talking about before, is they use their A and they use the C for the focus points, and they really don't ever use the B point. I know that was a big emphasis in Algebra 2, is to put that B up there, draw the box, and then your asymptotes were the diagonals. You can still do that. You can still do that. The line segment of length 2b is your conjugate axis for the hyperbola. The equations for the asymptotes. Y equals k plus or minus b over a times x minus h. If it's horizontal, and y equals k plus or minus a over b times x minus h if it's vertical. Okay, so a couple things here. I moved the k to the back, so it's more like slope-intercept form or point-slope form. I'm going to put that k in the back. Also, another easy way to think about this is that it is the number under y divided by the number under x. Alright, it just changes because with one way the a is under the x and the one way the a is under the y. So just think about the number under y, the square root of it, and then the square root of the number under x. Just like slope. Y is on top, x is on bottom. Okay, let the fun stuff begin here, huh? Sketch the hyperbola whose equation is 4x squared minus y squared equals 16. So we know that this is supposed to equal 1, so we're going to divide by the 16. So we'll have x squared over 4 minus y squared over 16 equals 1. Okay, there's nothing inside with my x or my y, so that tells me my center is at 0, 0. Square root of 4, my A is 2. Square root of 16, my B value is 4. Alright, A squared plus B squared equals C squared. C squared is going to be 20, so C is the square root of 20. 2 radical 5, or for graphing purposes here, about 4.5. Alright, X is positive. It's the front one. So our vertices are going to be determined by that. So we're going to have 2 to the left of the center and 2 to the right of the center. We're starting at 0, so that's pretty easy. So our vertices are going to be at plus or minus 2, 0. And then the same thing for our focus points. Plus or minus 2 radical 5, 0. Pretty easy when it's 0 for the X. You don't have to think very much. Okay. Let's get all this information on the graph and let's see where we're at. So my center is 0, 0. Vertices are at plus or minus 2, 0. And then my focus points are at plus or minus 2 radical 5. That's about 4.5 we said. Okay. Now this could be helpful here. Is putting in our covertices, which are going to be 4 up and down. 4 up and down from the center. And perhaps you remember doing this in Algebra 2 and making the rectangle in the middle. Okay, and then these would be your asymptotes. Alright. Now we should be able to get those equations. Okay, the number under, so it's 16, but it's going to be the square root of that, so it's plus or minus 4 over 2. And we didn't have any change in the X, and we also didn't have any change in the Y. We were at 0, 0. So this is plus or minus 2x. And that should be about right here. Up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. Okay, so we're going to go from our vertices and bend around the focus and follow the asymptote out. Ta-da! Fun times. Let's do another one. Sketch the hyperbola given by 9x squared minus 4y squared plus 8y minus 40 equals 0. Alright, so we're going to have our 9x squared minus 4y squared plus 8y. We're going to move the 40 over to the other side for just a little bit. I'll bring it back in a minute. Okay, we're going to pull off a negative 4 out of our y's and a blank to complete our square. Y squared minus 2y plus blank. Half of this is negative 1. Negative 1 squared is positive 1, so we add a positive 1 there. It's not really positive 1 though, it's tricky. It's positive 1 times negative 4. So you just really added a negative 4. So we're going to have to add a negative 4 on the other side. Okay, complete our square. Y minus 1 squared. On this side we'll have 36. Alright, now we're going to bring it back over. We're going to divide everything by 36. And now we should be able to get all the information we need. Okay, our center, 0, 1. Focus points. Alright, so let's see. We're going to have 4 squared. Nope, that is 4. So it's A is 2 and B is 3. So 4 squared, or 2 squared is 4, 3 squared is 9. Add those together, 13. And for graphing purposes, that's about 3.6. So it's a side-to-side one, so that's going to get added to our center. We'll have 0 plus or minus square root of 13, comma 1, or just plus or minus 13, comma 1. Vertices, okay, so not 4, so the square root of 4 is 2, so we're going to be adding 2 plus or minus 2, comma 1, 2, 1, negative 2, 1. Do we need anything else? Yep, our asymptotes. 3 over 2 x minus 0, and then we're up 1, so plus 1. So we have plus or minus 3 over 2 x plus 1. Alright, let's graph it. So our center's at 0, 1. Our vertices are 2 out in each direction. Focus points were square root of 13, which was 3.6. If you want to fill in your rectangle, these are up 3 and down 3. Alright, so 3 over 2, that's our slope here for our asymptotes, which fits perfectly with the corners of your rectangle. And we can follow those out. We've had all sideways ones so far. Alright, last one I think we're going to do for today. What are we getting to be here? About 18 minutes. So this is going to be just over 20 minutes. So that'll be a good one. Good partial lesson here for the day. That'll leave us with just a few problems for tomorrow. So find the standard form of the equation of the hyperbola having vertices 3, 2, and 9, 2, and having asymptotes of negative 2 plus 2/3 x and 6 minus 2/3 x. So the key there is the slope. We got plus or minus 2/3 x. We'll see how that's going to help us out. So midpoint between these is going to be 6, 2. That's our center. Okay. So we have 3, 2, roughly. 9, 2, 6, 2. So this is going to be a sideways one again. Alright, our distance from center to vertex is going to be a distance of 3. So we're over 3 squared. Okay, and then from our slopes, we can see the ratio is 2/3. So if the bottom number is 3, that's our x. The top one should be 2 for our b. 2 squared. So then our final equation here is x minus 6 squared over 9 minus y minus 2 squared over 4 equals 1. Alright, we'll call it a day there, folks. Let's look over our suggested homework problems for section 4. Do as many of those as we can.
We could also be looking at the quiz review problems for 10.1 through 10.4 and preparing for the upcoming quiz.
All right, we'll see you guys next time.